Another type of attack that is specific to web applications is a cross-site scripting attack, otherwise shortened to just XSS. So how does this type of attack work, and more importantly, how can we protect against it? So first of all, what happens with the cross-site scripting attack is we have a web application that doesn't properly validate or sanitize user-supplied input. Now, software developers should always use secure coding practices, which means they treat all user-supplied input, whether it's through a URL or through a field on a web form or anything like that, they treat it as hostile, assume it's malicious, and put it through the ringer, so to speak, to make sure that if we're asking for someone's name, that's all that was typed into the field. If we're asking for someone to put in a comment on a social media site, that where they type that in, we check it, and that's all that's in it is text strings, not special characters, not malicious code statements, because that's how this happens. So an attacker then would inject malicious code into a vulnerable website. Let's say it's a field on a web form that isn't properly sanitized. Now, what attackers will often do is use JavaScript. They'll enter the actual JavaScript commands directly in a field, for example, that might ask for a name, or a field that might ask for a comment for social media, whatever it happens to be. Okay, so they're entering in actual JavaScript code. Now remember, JavaScript's different from Java. Java runs server-side. JavaScript runs in the client web browser. And that's going to help explain this. So what happens is the attacker has injected some malicious JavaScript into the field in a web form, and it gets saved on that server. Maybe it's a social media post. Now, when other people go to view that post, it will execute when they click it, or depending on how the web app is configured, simply by opening up that post, it will execute that JavaScript. Now, where's that running? It's not running on the server. It's not Java, it's JavaScript. It's running in the client web browser that is viewing that post in our example. Depending on what that JavaScript does will determine how malicious the problem is. Is it reading files on the hard drive? What is it doing exactly? But the fact that we can have scripts execute on our client web browser session that were just injected by anybody in the world is very scary indeed. So let's take a look at how this actually manifests itself. So remember, we want to make sure that all user input is treated as hostile or untrusted. So then, let's take a look at how this works using what's called Metasploitable 2. Now, what's Metasploitable 2? Metasploitable 2 is a free downloadable virtual machine that contains a bunch of web apps that are intentionally vulnerable. So it's used for security researchers or security people like us to test things like cross-site scripting attacks. So what I've done is I've already downloaded that free Metasploitable 2 virtual machine. I've fired it up on my computer because I'm running VMware Workstation, and I'm connected to its IP address, as you can see here in my web browser. So what I want to do is I want to click this link for DVWA. What that stands for, sort of, is Darned Vulnerable Web Application. Not sure if I want to say the other one, but I think you can guess what it means. It's a vulnerable web app. If I click on it, what we want to do here is make sure that this sample vulnerable web app is set to low security. So I'm going to click DVWA security over on the left. Good, it's already set to low, which means I can test vulnerabilities like XSS, which we know means cross-site scripting. All right, let's do it. I'm going to run an XSS stored attack. Now that means that when someone enters malicious code like JavaScript, it is stored on the server. Okay, so what do we have here on the right? Oh, it looks like a sample guest book type of web page that you would see on almost any website. Okay, so I might enter my name. My name is Dan. What's the message? Oh, the message is going to be JavaScript. It's going to be like this. When you write JavaScript, if it were embedded on an HTML page, you would enclose the word script in a less than and greater than sign. It's an opening tag. Then you would write your code. For example, I'll just use the alert JavaScript function, which pops up a message. That'll be proof enough that this will have executed. In parentheses and single quotes, maybe, how about we say, you have been hacked. and close the single quote, close the parentheses, we have to add a closing script tag. So less than symbol, front slash script, greater than symbol. If you've ever coded in HTML or XML and stuff like that, you'll be familiar with how the opening and closing tags work. So I haven't actually entered a message when I'm signing into the guestbook, have I? Not at all. I've entered some malicious JavaScript. So, sign the guestbook. Okay, sign the guestbook. All right, right away the JavaScript executes, but that's for me. I'm the one that did it, so that's not really that important. I'll just click OK. So let's imagine then that a user is visiting this site. So now I'm playing the part of the victim that will execute that. So they're browsing the site, they're clicking on things, everything's just beautiful. Then they go, in this case, to the XSS stored link on the left, and what executes immediately? The JavaScript. So this is a cross-site scripting attack. Now, it could have been prevented, and it's really the responsibility of software developers. They need to make sure that they don't allow that type of statement to be within a field. Why on earth would that be allowed? You would never have a good reason to enter executable JavaScript into a message field on a web form. And so we want to be very careful then about how that is done in our environment. You need to make sure you're running periodic vulnerability scans to detect if this is actually a potential vulnerability on your web servers. So in summary, we have an animation where on the left, the attacker injects malicious code into a website, as we've seen, and in step 2, the website visitor unknowingly executes that code. Well, I guess in our case, it was knowingly because it happened to be an alert message, but usually it just runs in the background. The user doesn't even know that that executed.